In the decimal system of counting, there are many forms of numbers, but I want to speak about just two out of those numerous forms of numbers. I want to talk about the ordinary forms of numbers and the index form of numbers. To draw a contrast and possibly bring out their meanings, let me isolate one number. Please pick a paper and pen and write 1 hexillion. Are you through with that? Okay, if you are through with writing that figure I just called, how many zeros did you write after 1? If you just wrote 1 and 21 zeros after it, you are correct. That is how to write 1 hexillion in figures. But don't forget that that is just based on the decimal system. The correctness of that figure is based on the demands of decimal system of counting. Okay, now do something else. Beside that figure, write 10 raised to the power 21. That is, write 10. Then above it, write 21. We just call it, or you should call it, 10 raised to the power 21. Let me inform you, if you don't know anyway, that the two figures you wrote are the same. The two of them appear different, and yet they define the same figure. That figure is 1 hexillion. That first one, which you wrote with 21 zeros, is said to be in its ordinary form. But that one you wrote by attaching 21 to 10 above it is said to be in its index form. So now what will you say is the meaning of ordinary form of a number? And in contrast, what will you say is the meaning of index form of a number? Anyway, while you anticipate the definitions of these two forms of numbers, let us first state one advantage that index form has over the ordinary form. At least you can see that in writing 10 to the power 21, you spent less time, spent less energy, and spent less space in writing it. That is wonderful. That is exactly what was observed in the past when men of those days encountered numbers that were so long and cumbersome in writing. So they chose to contract the writing so as just inform people what they have done. That is, making the writing brief so that they can save space, or they could save space, time, and energy in writing such numbers. So, what then will you say was the central objective of inventing such form of writing? It was to save space, to save time and energy in writing some figures which exist in decimal system. But a challenge came after the invention of that index of a number. What challenge? The challenge is that it was easy enough before its invention to carry out some basic number operations with ordinary forms of numbers. It was easy, comparatively though, to add, subtract, multiply and divide with numbers in their ordinary forms. But now that index forms have come to stay, we are faced with a challenge of carrying out the same basic number operations using numbers in their new forms, the index form. That is a challenge that came up after the index forms were invented. In this presentation, I seek to recast what already exists as laws of indices. I want to recast so we learn again, perhaps with this medium, how to add, subtract, multiply and divide numbers in their index forms, especially carrying out multiplication and division of numbers. In fact, this dominates this entire work. Addition and subtraction may come your way, but perhaps afterwards. In this work, we are going to be seeing more of how to divide and multiply numbers in their index forms, and their derivatives also included. There are some features of this work that you may find refreshing. 1. Each section has numerical experiments, and after numerical experiments, there are laws born out of such experiments, that is, proofs of the laws of indices. Each section begins with a numerical experiment. Then next, out of the observations made from the experiments, laws are born. So such experiments help us to be sure that the laws of indices are correct. So we have 1. Numerical experiments. 2. The proofs of laws of indices. 3. Worked examples. And then 4. The feedback from learners. And in this case, I call it the checkpoints. Each lesson presents its own challenge, and beautifully enough, each lesson has one central theme it is presenting. Because this work is broken into lessons, let it be that each lesson leads to the other lesson. But all lessons together, united, will make you better positioned for learning the entire work of laws of indices. Also, let me admit that some of the things you're going to see are things you have known before. If you see what you have known before, there is no point waiting. Just adopt the skip and search approach towards finding the other things you don't know. You will definitely learn new lessons in this work. But if you come to the point that what I'm saying is what you have known before, you can skip and then search through for the purpose of getting the lessons you don't know right away or right now. It promises to be an exciting presentation. Please cooperate with me as I present the laws of indices using numerical experiments, proofs, worked examples, and the feedback from students. When I spoke on powers and roots, I took some time to explain why numbers came to be expressed in their index forms. That is why indices were invented. In this topic of laws of indices, I think it is also necessary for us to briefly recall why indices were invented. Let me use this number, 100 million, to explain briefly why indices were invented. This number, 1 million, is in its ordinary form. Let me write it in index form. And with index form, we now realize that it was important that people invent indices. Again, let me write this 100 million in index form. Yes, this is the index form of this number. It is 10 to the power 8. Now, with this, what will you think is the reason why indices were invented? Surely, you can discern from here that this 10 to the power 8 takes less space, it takes less energy, and it takes less time to write. And in mathematics, we're always interested in saving energy, saving space, and saving time. It is therefore important to note that Indices were invented for saving these three things. That is space, energy, and time. When we add, subtract, multiply, and divide with numbers, we always see that the numbers taking part in such number operations are in their ordinary forms. But now that we have known that numbers also exist in index forms, how are we able to multiply, divide, subtract, and add numbers when they are in their index forms? And that takes us to the very first objective of this lesson, and that is the meaning of laws of indices. To get to understand the meaning of laws of indices, let us consider 2 to the power 3 times 2 to the power 2. That is getting answer to this number operation. I wish to get the answer to this number operation in two ways. And after the two ways, I present to you what I mean or what is meant by laws of indices. Please, let me start with the first one. The first says this: 2 to the power 3 means the same thing as 2 times 2 times 2. It thinks that this means this. I hope you agree with me. What about this? 2 to the power 2 means 2 times 2. It means that this is the same thing as this. Therefore, 2 to the power 3 times 2 to the power 2 means 2 times 2 times 2, then times 2 times 2. Then, when the brackets are removed, nothing else is done except that the brackets are off to give us 2 times 2 times 2 times 2 times 2. That is 2 appearing 5 times. If you express this in index form, what you're going to get is 2 to the power 5. And again, if you evaluate this, you're going to get 32. Why? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So the answer to this expression or number operation is either 2 to the power 5 or 32. This is just what we are required to do with this. What we have done here, or what I have done here, is the primary operation expected to be carried out in the case of 2 to the power 3 times 2 to the power 2. Whichever way we adopt to carry out this operation that will give us 32 as the answer is also acceptable, especially when tested more than once. Let me carry out a different number operation on this 2 to the power 3 times 2 to the power 2 to get the answer as 32. If you watch this first number operation, you realize that it takes a lot of space to get this 32 as the answer. It is important that for that reason, we seek to shorten the process. That is, we look for a way to shorten the process of multiplying these two numbers. How do we do it? We look at how these two numbers, when multiplied, give us this 2 to the power 5. If you watch it, we can deduce something from it. With this second line of number operation, let us see that we can deduce. 2 to the power 3 times 2 to the power 2 gave us 2 to the power 5. Could it be that 2 to the power 3 times 2 to the power 2 will give us 2 to the power 5 because if we add 3 to 2 to give us this 5, okay, that means 2 to the power 3 times 2 to the power 2 will give us 2 to the power 3 plus 2. That is this power plus this power. That is what I mean by this 3 plus 2. and the single 2 remains the common base. This and this are the same, and when evaluated, the answer is still 32. Now watch this procedure and watch this procedure. Both of them gave us 32 as the answer, but this second one is shorter than the first one. Which one do you think you should prefer? If this second one is correct and not a coincidence, this is obviously easier and better to be adopted if we have to save energy, space, and time. It is important to find out if it is a coincidence or just by chance that this times this became this. It needs carrying out more operations that resemble this before we come to know that this is correct. Please carry out many other operations that resemble these two. Just write a number, raise the power a given number, and the same number to another power or the same power, and apply this same process of adding the powers to check whether it is by coincidence or chance that these two, when multiplied, came to give us 2 to the power 5. When I did my own, I discovered that it is not by chance that this came to be so. In actual sense, I have come to learn that when an index form of a number multiplies another index form of a number and the two are in the same base, that the answer will be that same base raised to the power the sum of their powers. Therefore, 2 to the power 3 times 2 to the power 2 being equal to 2 to the power 5 is not a coincidence. It has come to be a law, because if you test it again and again with other expressions or other number operations, you will see that adding the powers to give the power of the result is just correct. Since we have two methods of solving it, the primary method of expanding the powers to get the answer, and then second method of observing the shortcuts from the long process. So this alternative method of multiplying numbers in the index forms, if it becomes consistent, is what we refer to as law of indices. What if then you are told to define laws of indices? What will you say? Now, let me write what it is, and you compare it with what you are thinking. What is law of indices, or what are the laws of indices? What is their meaning? That is what we seek to achieve. Here it comes. Laws of indices are alternative methods of carrying out number operations using numbers in index form. With what has happened here, do you get a sense of this statement? It says alternative methods. That is, other methods apart from the traditional method of expanding numbers in the index forms. This is the actual method. The traditional method of multiplying numbers in index forms is like this. So this is the traditional method, and this is alternative method. When you hear law, what should come to your mind? In this case, the law is not just about rule and regulation. When we speak about laws in sciences, mathematics included, we mean observations that are consistent. I observed that this is correct from this first line of operation. The question is, if I carry out a similar observation with other number operations which are similar? Will I consistently observe that we get this power by adding these two? If it becomes consistent, it becomes a law. In other words, laws are used here to depict consistent observations. Therefore, again, laws of indices are alternative methods of carrying out number operations using numbers in index form. Now that you have known what is the meaning of law of indices, you may also want to ask, and you may also want to get the answer as to whether it is every kind of number operation in index that will have a rule or a law. Notice that adding 3 to 2 to get this power 5 is done when the numbers are multiplying. What if what is here is not a sign of multiplication? Therefore, that we added 3 to 2 when multiplying is correct. But what if it is 2 to the power 3 plus 2 to the power 2? Is there a law that guarantees the correctness of the result? That is there any alternative method of solving that kind of problem? 2 to the power 3 plus 2 to the power 2. What if it is 2 to the power 3 minus 2 to the power 2? What if it is 2 to the power 3 divided by 2 to the power 2? Are they all possible? That is there in each case an alternative method of carrying out such actions or number operations? Anyway, experience shows that it is not all number operations, all basic number operations with indices that possess laws. It is only multiplication and division and their derivatives that actually have come to possess laws concerning how to carry out the number operations. So this is multiplication. Next is division and things that come from the two. That is derivatives of multiplication of index numbers and division of index numbers. There are no laws for adding indices, no laws for subtracting indices, at least as long as today's practice of number operations in indices is concerned. So in this topic, we are going to be concerned with laws of multiplying, laws of dividing numbers in their index forms, as well as laws of carrying out derivatives of multiplication and division of numbers in index forms. It is these alternative methods of multiplying and dividing numbers in index forms that we refer to as laws of indices. It is important to note that while we learn to multiply and divide numbers in the index forms, that is important caution that we have to take note of. What is it? If that caution is not taken note of, we make mistakes and even go into outright errors when multiplying and dividing numbers in index forms. What is the caution? And that's the caution. Laws of indices apply only, stressed, only if the bases are equal. This law applied because the base is the same, 2 here, 2 here. If what we have here is 2 and what we have here is 3, for instance, this law won't be applicable, and that is based on observations. Therefore, take this caution that for the laws we're going to see to apply, the basis of the numbers in the index forms must be the same. As earlier stated, all the laws of indices that we're going to see involve multiplication and its derivatives.
and then division and its derivatives, all involving numbers in their index forms. And that takes us to the second objective, that is laws of multiplication and derivatives.